we've been given that suppose A and B denote the distinct real roots of x squared positive 20x negative 2020, right? So this is a equation for which we got A and B being the real roots, and C and D denote the distinct complex roots of, say, x squared. This is positive, this is negative, followed by positive 2020. Now we are expected to find the value of A negative C times AC, positive AD times A negative D, positive BC times B negative C, positive BD times of B negative D. This is required. Now you've been given four choices. Choice A is 0, choice B is 8000, C is 8080, and choice D 16,000. So the question is straightforward. Let me just start off with the first equation. Consider x squared positive 20x negative 2020 equal to 0. Since A and B are the roots, so this would mean sum of the roots A positive B is equal to negative 20, and product of the roots is equal to C over A. So that's going to be negative 2020. Okay, now consider the other system. X squared negative 20x positive 2020 is equal to 0. Now from here, since C and D are the roots, complex roots in fact, okay, so this would mean C positive D is equal to 20 and CD is equal to 2020. So we got two important sums and two important products. Now we are expected to find the value. So consider the given system. I'm writing it in this fashion. AC of A negative C, positive AD of A negative D, positive BC of B negative C, positive BD of B negative D, right? Just distribute the quantities. AC times A, this is going to be A squared C, negative A times C squared, positive A squared D, negative A times D squared, B squared C, negative BC squared, positive B squared D, negative BD squared. This is what we have got. Now what I wish to do is I would have to club this with this, and I would get C positive D, that's fine. And then if I were to club, I got a B squared here. If I were to club a B squared here, okay, I can club these two together. So B squared is taken out, C and D would be there, and what else? I have a BD squared, negative BD squared, that wouldn't come in much handy for us, and I got a BC squared, and Okay, I can club these two together, right? So I take a negative sign out, I take a c squared out, so I would get a positive b, right? Fair enough. So that's done. And what else remains? So I've got a ad squared and negative bd squared. So if I were to take a negative, if I were to club this with this and this, I would have a positive b out, right? So this is what I have got. So I've taken care of this and this. This is also done. This is done. This is done. And this is done. And everything is exhausted. That's fine. Now all that remains is to substitute the values for c positive d, which is 20. And 20. And then for a positive b, which is minus 20 and negative 20. So this is going to be equal to 20, 20, 20, 20. I can take 20 out. This would give me a squared positive b squared, negative, negative, positive, c squared, positive d squared. Now 20 is there. I can write a positive b, in fact a squared positive b squared as a positive b raised to the power of 2, followed by negative 2ab. Similarly, c squared positive d squared, I can write it as c positive d raised to the power of 2, negative 2 times cd. So this is equal to 20 times. Now a positive b is 20, right? Negative 20 raised to the power of 2, negative 2 times ab is negative 20, positive c positive d is 20 squared, negative 2 times cd is 20, okay, fair enough. Now negative, negative, positive, and you got 2 times of 20, right? So this is negative, this is positive, so they both gets cancelled off. And what have we got? We got 20 times of this 400, and then you got 400. This is 20 times of 800, which is equal to 00016. So this is the value. 16,000 is the value. So where do we have it? Let's go and check out the choices. You see that these are the choices, and clearly 16,000 is waving at us. So that is the solution for this question. Students, will go on to the next one.